What's up? I'm Vin, and today I want to take a look at an angle of elevation and depression word problem. So we're looking at this question here, and we're starting with some building. So I'm going to draw a rectangle here to just represent any building. And what we're told is that if we look upwards from the base of the building, so we're at the foot or the base of the building here, and we look upwards at 22 degrees, that's going to help us see the top of some tree. So here's our, let's say, 22-degree angle coming from the bottom here. So this angle of elevation over here is 22 degrees, and it's going to help us see the top of some tree. So we'll just draw some tree. So there's the tree over here. This is just modeling the scenario of the word problem. So that's for the first part of the question. But then next we're told that if we're at the top of the building up here, and we look down at an angle of depression of 50 degrees, we could also see the top of the tree. So I'm just going to extend the horizontal line across like this, because anytime you're talking about angles of depression, it's always relative to the line parallel to the ground here. So I'm going to draw this line over here to show this is our angle of depression, 50 degrees. It's going to be located over here. Okay, so now I'll just draw in the other lines to kind of complete this picture here. So here is our other right triangle that we're going to need. So the actual question here is, to the nearest thousandth of a foot, how tall is the tree? We have to answer, but we also have to answer how far is the building from the tree. So if we give it labels here, we're trying to say how far away is the tree from the building. That's x. We'll call that value x over here, so we have to solve for x, but we also want to know how tall is the tree. We'll call this y. So we have to solve for x and y in this question. We were also told that the top of the building is 150 feet tall. So this entire distance here is going to be 150 feet. And what I want to do to answer this is I'm going to draw in another point here that is directly across from this point, so that when I draw this line in, that this is going to make another set of 90-degree angles. And I'm able to do this because this is forming a rectangle. So if I locate this point here, I'm going to locate the point equal height, if I call this y over here. And that's going to allow me to draw in another line that's parallel to both of these horizontal lines here. So because I'm drawing in more rectangles, I could say if this thing is y, this thing is y. And if this value across here is x, then this is x. And this value up here is x, but I don't want to draw in too much stuff. So this diagram now is going to help us answer everything that we need. So what I want to look at here is that if this angle is 50 degrees, because I have a rectangle and these sides are parallel, then I could say that this angle down here is also 50 degrees. And another idea I could use is that, let's say I call this value over here z temporarily. Then I could say that z plus y, this segment plus this segment, is equal to 150, which tells me that z is equal to 150 minus y. Now, if you could just do that kind of math in your head, then awesome. But I just want to show why I'm labeling this part over here as 150 minus y, this distance from here to here. So we're just going to label that 150 minus y. So now we have enough information to set everything up to answer this. So I want to look at these two triangles here. I'm going to look at this right triangle, and I'm going to also look at this right triangle over here to help us solve for x and y. So first what we'll do is we'll talk about this triangle. If I set up the ratio tangent of 50 degrees, and remember tangent, the ratio for tangent is that tangent is equal to the ratio of the side opposite, which in this case is 150 minus y, over the adjacent side, which in that case is x for that first right triangle. But now if I look at this right triangle over here, I could say that tangent of 22 degrees is equal to y over x. So we could say tangent of 22 degrees is equal to y over x. So now with these two equations, we can do a bunch of algebra now to solve for x and y. So what I want to do is I want to solve these equations both for x separately. So what we're going to do is for the first one, and we'll section this off, is if I multiply each side by x, or if I cross multiply here, I have x times tangent of 50 degrees is going to equal 150 minus y. And when I solve for x, I'm just going to divide both sides by tangent 50. I have 150 minus y over tangent 50 degrees. And that's one equation we have here for x equals. Now the other equation I could get by cross multiplying here, and I have x times tangent of 22 degrees equals y. And now this tells us that x is equal to y divided by tangent of 22 degrees. So now that I have two equations involving x, what I'm going to do is I'm going to set these two equations equal to each other. I'm going to set this equation equal to this equation over here. So I have 150 minus y over tangent 50 is equal to y over tangent of 22 degrees. And now the goal is to just solve for y. And we'll just go ahead and do the algebra here. We could cross multiply first, and we'll have, let's say if I do 150 minus y times tangent 22, I have 150 tangent of 22 degrees minus y times tangent of 22 degrees equals, and I have y times tangent 50. So if my goal is to solve for y, I'm going to get all the y terms on one side. So I'm going to add y tangent 22 on both sides. So what we have at this step, once these terms cancel, we have 150 tangent of 22 degrees equals, and notice I have y tangent 50 plus y tangent 22. So I could factor out a y, and I'm left with tangent 50 plus tangent of 22. And of course, I'm including the degrees here. So if I want to solve for y, I'm just going to divide both sides by this factor. And this is going to give us one of the values that we need. So we're just dividing by that factor here. So we have divided by tangent of 50 degrees plus tangent of 22 degrees. So this cancels out, and this tells us here that y, and I believe in the question they want us to round to the nearest thousandths place. So over here in the calculator, I'm going to press alpha y equals enter just to set up a fraction. Notice I am in degree mode, so that's like an annoying way to lose points if you forget to change to the correct unit here. So we have 150 tan 22. That's in our numerator, divided by tangent of 50, close the parenthesis, and then plus tangent of 22. So we work this out, and to the nearest thousandths place, this is going to be 37.978. So we have 37.978, and this was talking about the units were feet, so we're going to leave this in feet. And the next thing we have to solve for is x. So we think about what we just found here. Well, we were told that x is equal to y divided by tangent 22. So if x is equal to y divided by tangent 22, so we'll just write that over here, then all we have to do to solve for x is just plug in what we found over here. So we could just take our answer that we just found and divide by tangent of 22. And we get 93.998 we're going to round to. So we have 93.998 feet. So this answers the question here. The height of the tree was y, and that's 37.978 feet. So we could even label that and say this is the height of the tree. And x represented the distance from the tree to the building. So the distance, we could say, between the tree and building. Okay, so that is our solution here. So this is going to wrap up this video on the angle of elevation and depression word problem. If you found this video to be helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topics you want me to cover in the comments section below. And thanks for watching.